Hello students, in world of numbers, we will see exercise 3.5. First question, without performing long division, determine which of the following rational numbers will have terminating decimal and which will be repeating. So you know very well a rational number is in the form of p by q, where q is not equal to 0 and p and q are primes. Okay, which means it will not have any common factor. Then if suppose q is equal to 2 to the power some number into 5 to the power some number, means then the number will be will have terminating decimal. This will have terminating decimal. Otherwise the number will be the non-terminating number when the denominator is in the form of 2 power m and 5 into 5 power n, which means m and n are any number, any whole numbers. Okay, if suppose 2 power 0 into 5 power n means anything power 0 is 1, so we will be having only 5 power n. Or sometimes q is equal to 2 power some number and 5 power 0, which means 2 power only 2 power m will be there. So only 5 power n or only 2 power m or 2 power something into 5 power something means that number will be terminating decimal. Other numbers are non-terminating numbers. Let's check the first number 7 by 20. So without performing the long division, we need to check like this. 7 and 20 not having any common factor, it is there in the lowest form, that is standard form. We cannot simplify this further, but 20 can be written as 2 power 2, that is 4 5s are 20. You can write like this. You can do your prime factorization and write 20 is the easiest number, so I am writing directly. So which is nothing but 4 2s are 4 5s are 20. So 4 can be written as 2 to the power 2 into 5 power 1. So the denominator is in the form of 2 into 5, which means 7 by 10 has terminating decimal. So 7 by 20 has a terminating decimal. What about 4 by 15? Look at there, 4 by 15. Again, 4 and 15, no common numbers. This is already in the lowest form, standard form. First confirm that, then you can do the prime factorization. 15 can be written as 3 into 5. So we cannot see 2 there. Other than 2 and 5, the factor is 3. The 3 is the prime factor which appeared there in the denominator. That means non-terminating decimal. So this rational number 4 by 15 has non-terminating decimal. Look at 13 by 250. Again 13 and 215, there will be no common numbers. Now perform your long division prime factorization for 250. If prime 5 is a prime number, if I am taking 5 is a 25, once again 5, 10, once again 5, 2. So this is nothing but denominator can return in the form of 2 power 1 into 5 power 3. 5 raised to the power 3. So again only the denominator has the factors 2 and 5. So it will have terminating decimal. So we no need to find the long division. Without finding long division, we can see the denominator q, which is in the form of 2 power something or 5 power something or 2 into 5. Then we can write which has terminating decimals. Now look at the next question. Second one, perform the long division for 1 by 3. Identify the repeating block of digits. Does it show cyclic properties? If you evaluate 2 by 13, now compute 3 by 13 and 4 by 13, etc. What do you notice? So perform 1 by 13 long division. Okay. So do the long division. So how to do? 113, you cannot divide, keep dot. So 0, again you cannot divide, then one more 0. So how many times? Like this if you are doing, you will be getting 7 times. Then one more 0. See, it goes on. When you are getting the number repeated over there, we can stop the division. We cannot divide, so 0, 0, again look at there, 7 times 91. So, yes, so same order repeated over there. So we will stop with this. Let us 1 by 13 has the decimal part 0.07692 0.07692 0.07692 etc. Okay, this is the decimal part of this number. Same like this, you need to perform for 2 by 13. Okay, you divide and find, divide and check. This will be the decimal for 2 by 13. Same, I did know like that. You divide and check it. So what we will be getting? 153846 153846 153846, like this, the number repeated over there. So how to write this? Look at here. See, from 0 the number repeated. Here also the number repeated. So this is nothing but 0.076923 bar. These are the number repeated over here. So 2 by 13 is equal to 0.153846 bar, which means it has what property? Cyclic property. Okay. So repeated blocks. We are having repeated blocks. Both the numbers are having. Now look at one more difference. Now 1 by 13's repeated block is what? 0, 7, 6, 9, 2, 3. No, now I am going to multiply this with 2. So I will be getting 6, 4, 18, 13, 15. So look at this, 1538 is here. So 1 by 13's the repeated block multiplied with 2, you will be getting 2 by 13's repeated block. So what will be for 3 by 13? Without doing the division, we can write. So again, that repeated block of 1 by 13, 0.76923, multiply that with 3 because numerator is 3. So 9, 6, 27, 18, 20, then 21, 23. So which is nothing but 0.23069 bar. So like that 4 by 13. So 4 by 13 means you need to multiply that with 4. Which one? 1 by 13's repeated block 076923 into 4. Multiply this 12, 9, 36, remaining 6, 24, 28, remaining 2, 24, 12, so 307692 here 0.307692 bar. Use your calculator and check it. These are the number repeated over here. The bar is not for 0, only for the decimals. So here we need to put the bar for the decimals. This one. Yeah. Okay. So we can see the what? Blocks. We can see the repeating blocks and cyclic properties here. Let's see the next question. Classify the following numbers as rational or irrational. So how to classify a number rational or irrational? Before that, we can see the types of decimal. Decimals, you know the decimals, no? There are two types of decimals. One is terminating decimal. Another one is, this is terminating decimal. Another one is non-terminating decimal. Which means terminating will have an end. For example, 2.35 is a terminating decimal. 0.42735 is the terminating decimal. Any number, if it has end, that will be called a terminating decimal. Now, non-terminating decimal has two parts. So, two types. One is recurring decimals. Non-terminating, one type is recurring, another one type is non-recurring. Recurring and non-recurring. For example, if same number repeated over there, 5, 5, 5, 5, 5, etc., recurring, then 3.727272 like this. Otherwise 0.1952. So these are called recurring decimals. Non-recurring means different type of numbers, 1, 2, 5, 9, 6, 0, 0, 0, 5, 2, 3. Some numbers repeated over there. It cannot have an end. So these are the numbers. Now, in this terminating number and non-terminating recurring numbers or rational numbers. So these two are which one? Terminating and non-terminating recurring. These two are rational numbers. Non-terminating non-recurring number, irrational number, not an rational number. So two types of number. One is rational, which and all rational? Rational numbers terminating decimals and in non-terminating decimals non-terminating recurring decimals. These two are rational numbers, but irrational number nothing but non-terminating, non-recurring. So these type of decimals, non-terminating, non-recurring decimals are irrational numbers. So with this knowledge, we can find easily whether the numbers are terminating or rational or irrational. So when we are having radical symbol, the symbol like this, no, so these symbols are called radical symbols. Immediately we cannot say this is an irrational number, we need to check. So square root of 81. What if any square number is inside or it is a perfect square, we need to check because square root, which is nothing but 81 is nothing but 9 into 9 is equal to 9. So first one is terminating decimal. Sorry, first one is rational number. Second one, so this is rational number. Second one, 12. So 4 3s are 12. It can be written as 2 root 3. As you know very well, root 3 is an irrational number. So this is irrational number. Now look at the decimal. As I told to you, here 0.3333, the number, same number repeated over here. So this is non-terminating but recurring number. So this is rational number. We will check that. Rational number, how to check means rational number has P by Q form. We can check. Take x is equal to the given number. 33333. Okay. Now only one digit repeated over here. So multiply this with 10. Both the sides with 10. You will be getting 10x is equal to. When we are multiplying the decimal with 10, the digit right moves one decimal right hand side. So 3.33333 will be there. Now subtract both. 10 minus x is equal to 0. Because our aim, we need to delete the decimal parts. Now 3 minus 3 is 0, 3 minus 3 is 0, 3 for all the 3's vanished. Now decimal part vanished. 3 minus 0 is 3. Then 10x minus x is 9x. So x is nothing but 3 by 9, which is 1 by 3. So our given number, that is 3.333 etc. is nothing but 0.3 bar. You can write 3 bar, which can be written as 1 by 3, P by Q form. Therefore, the non-terminating recurring numbers are rational numbers. Look at the next one. What type of number? 0.12345. Again 12345. See 1 2 3 4 5. Again this place 1 2 3 4 5. Again here 1 2 3 4 5. So this is nothing but 0. Look at dot dot dot. So non-terminating number but recurring number. 0.12345 bar. Okay. So this is non-terminating recurring number. So definitely it is a rational number. So how to check whether it has P by Q form or not? Take the given number as x. 0.12345, 12345, etc. x. And how many digits repeated? 1, 2, 3, 4, 5 digits. So multiply this with lakhs. So 1, 2, 3, 4, 5 x is equal to, when you are multiplying right hand side also lakhs, the digit will move 5 times this side, right hand side. So 1, 2, 3, 4, 5, 0.12345, etc. Now subtract the x here. X is nothing but 0.12345, etc. While we are subtracting this 2, okay, we are subtracting. So here you will be getting 99999 x is equal to, so all the decimals get cancels. We are having 1, 2, 3, 4, 5. So our x is nothing but 1, 2, 3, 4, 5 divided by 5 nines. 1, 2, 3, 4, 5. So we are having P by Q form. Therefore, the number is a rational number. Look at the next number. 1.01, and here only 1 0. Here 2 zeros. Here 3 zeros. Here 4 zeros. Which means the block is not repeated. Different type of numbers are repeated there. It is not repeated in a uniform manner. So this is non-terminating, non-recurring number. So we can call this as irrational number, because we cannot express this in the form of P by Q. Let's see next, 23.56018561239874790120. That's all. With 2 0 it ends. No more dots. So ends. It is a terminating decimal, which means rational number. Terminating decimal, so rational number. Then they are asking explicit fraction in case of rational. If you want to write this in the rational, means count the decimals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 decimal. So write all the number in numerator, that is 2, 3, 5, 6, 0, 1, 8, 5, 6, 1, 2, 2, 3, 9, 8, 7, 4, 7, 9, 0, 1, 2, 0 divided by that many zeros. That is 1, 2, 3, 4, 7, 8, 9, 10, 14, 18, 19, 20, and this many zeros. So this is P by Q form, so that we can write that in P by Q form. So it is rational number. Last question. The number 0.9, which means 0.0 is the rational number using algebra. X is equal to 0.9 and multiply with 10. Subtract. Already we did this method. No, explain why 0.9 is exactly equal to 1. So you know very well the procedure. Take the number x, the number as x. So 999, etc. x. Only one digit repeated, so multiply both the sides with 10. The decimal moves one digit to right hand side, so it will become 999. Then subtract this and x. X is nothing but 0.999, etc. This is also etc. While we are subtracting, left hand side 10 minus 1 is 9x. Right hand side all the decimals are cancelled, so you will be getting 9. Now x is equal to 9 by 9. So x is equal to 1. Therefore, we are telling 0.999 etc., which is equal to 1. Thank you.